This is the function f of x, this crazy piecewise function. In this video, we will perform the transformations indicated by this function expression. So what we're going to do is pick some key values and do the transformations one point at a time. So let me get a large table of values ready to go. Okay, so let's just go piece by piece. So this will be these will be my x values and my y values. I think we're going to need another column for the transformed values. Now let's talk about the transformations real quick before we pick the points. Some transformations affect the y values, and those will be the transformations that are outside of the function, like the 2 and the 3. For that reason, when we do our transformations, we're going to take the y values and we will do 2y plus 3. We're doing the two transformations that affect the y values. There is another transformation that will affect the x values, and those transformations are always inside the function, and the only one is this little negative sign. But because of that, we're going to do the opposite of all the x values. So these are the transformations we're going to be doing. Now let's go ahead and pick the key points. Let's start with this flat little guy right here. I'm going to do as few points as I can. So I think we can get away with just 3 points from this. So I'm going to pick this point right here and this point right here. And I definitely have to use this point right here. So the first point is -7, comma 2. So I'm going to have -7, comma 2, and then -4, comma 2, and then -2, comma 2. All right, -2, comma 2. Now this one has to be an open circle. So I think just off to the side over here, I'm going to put an open circle to remind me that this one needs to be an open circle. All right, so I'm going to draw a line because that's going to be the end of this portion of the graph. Okay, now for the next portion of the graph, I'm going to use this point right here, and this point right here would be good. I've got the asymptote here. I should include that, all right? So I'm going to include the asymptote. All right, I'll show you what I mean by that in a second. I'm going to also include this point right here and this point right here. Okay, so I've got -2 for my x value, so I'm going to have -2. For the y value, I'm going to have to come back to that in a second. All right, I'm going to come back to what the y value is. But the next point, I've got 0, comma -1, so I'm going to have 0, -1. And then I have this asymptote at +1. So at +1, I have this asymptote. So maybe I'll just put A here for asymptote. Okay, and then at 2, we have 2, comma 1. All right, we have 2, comma 1. Now we need, I really need this 4 in here. So this is going to be 4, comma something. So I'm hesitating because these values on the ends, this is going to be, the y value will be some kind of a decimal or a fraction. So let me think about this for a second. All right, I don't see any way around this. So the parent function that we're dealing with here on this, this portion of the graph, the parent function is y equals 1 over x. All right, and a long time ago we learned, we memorized, hopefully, that the parent function 1 over x has this type of look to it. All right, we're going to have a branch here, and we're going to have a branch here. The x and y axes are the asymptotes. So compare that to what's going on here. The x-axis is still an asymptote, so that means there's no vertical shift. However, instead of the y-axis, we have a new vertical asymptote at 1. In other words, this graph has been shifted 1 to the right. And the way we get a shift of 1 to the right is if we put x minus 1 in the denominator. Okay, so this is the equation of this middle part of the graph. All right, y equals 1 over x minus 1. So I can use this equation to get the y values. All right, I don't see any way around it. So if I do -2, for example, then that would mean I would have y equals 1 over -2 minus 1. So that would be y equals 1 over -3. Okay, so this is going to be -1/3. So I've got -2, comma, -1/3. Now at 4, so what if I were to put in 4? If I put 4 in there, then I've got 4 minus 1, so that's 3. So that's +1/3. Okay, so that was a little bit extra, but you got to do what you got to do, people. All right, now let's clean that up and move on to the third and final portion of the graph. Okay, now the third part of the graph is this cubic part right here. I'm going to need this point and this point. I want to have this point, and okay, that might be enough, but I would love to have this point as well. I'm just not sure it's going to fit on the graph, but I'm going to go ahead and write it down. If it doesn't fit, it doesn't fit. All right, so the first point is 4, -1. So I'm going to have 4, -1. That's another open circle, so just put a reminder here for us. Then we have 5, 0. All right, so we have 5, 0, and we have 6, 1. And we have 7, 8. All right, that is great. So now it's time to do these transformations. All right, so as I do the transformations, I'm going to have, so opposite of x, so that's just going to be 7 and 4 and 2. Okay, I'm just doing the opposite of all the x values. And I'm going to have 2, 0, -1, -2, -4. And -4, -5, -6, -7. All right, we just did the opposite of all the x values. Now, the y values are a little bit more complicated. We have to do 2y plus 3. So 2 times 2 is 4, plus 3 is 7. So these are all the same. So these will all be 2, 7. Okay, now this is a little bit ugly. So I need to do 2 times negative 1/3 plus 3. All right, so it's a little bit of a pain. So remember, this is 2 over 1. You multiply straight across. So this is going to be negative 2/3 plus 3. So that's going to be negative, whoops. That's going to be negative 2/3 plus 3 is the same thing as 9 over 3, right? 9 divided by 3 is 3. Like denominators. So that's going to give me 7 over 3. Okay, 7 over 3. What is that as a decimal? Grabbing my calculator really quick. Okay, 7 divided by 3. All right, that is approximately 2.3. Okay, so I want that in purple. So this is about 2.3. Okay, negative 1. So negative 1, 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. All right, we have an asymptote here, so let me think. Yeah, so there's still going to be an asymptote here. Okay, now 1. 2 times 1 is 2, plus 3 is 5. So that is going to be 5. All right, now I got to deal with this fraction business one more time. So imagine that this was positive 1/3. Okay, so that's going to make this positive 2/3. So that means I'm going to have 2/3 plus 9/3. So instead of being 7/3, that is going to be 11/3. Okay, and 11 divided by 3 is approximately 3.7. Okay. All right, I'm just going to clean that up in case I need the space. All right, last part. 2y plus 3. So 2 times, well, we already had negative 1 before, so that's going to be 1. 0. 2 times 0 is 0 plus 3 is 3. All right, we already had 1 before, that was 5. Now 8. 2 times 8 is 16. Wow, this is going to be way off the graph. But 2 times 8 is 16, plus 3 is 19. So obviously that's not going to fit on the graph, but we've got it anyway, whatever. So all we have to do is graph it now. Remember, these are the old points inside of here. So we're going to ignore those for the rest of this problem. We're going to be ignoring these values. And instead, we'll be using the new x and y values. Okay, so let's see what we've got. So first we're looking at this little horizontal part right here. And let's see what happens. So 7, 7. All right, so that's way over here. 7, 7. That's a point. 4, 7 is right there. And 2, 7 is right here. Now remember, this one is the open circle. So kabam. All right, so here is that horizontal piece right there. All right, that is what became of this. All right, now let's do the purple stuff. Okay, maybe we should go ahead and put the asymptote in here right now. So the asymptote is at -1. Okay, that's going to be the new asymptote is going to be at -1. So there's going to be an asymptote like over here somewhere. So let's go ahead and get that represented. Okay. Now 2 comma 2.3. Okay, so that's going to be 2 comma, all right, 2 comma 2.3. 2.3 would be right here. You know what? I'm remembering something else. The horizontal asymptote, we need to pay attention to where that is as well. So look, the horizontal asymptote was the x-axis. Because of the plus 3, that's going to be shifted up 3. So we know there's going to be a new horizontal asymptote that's going to be right here. So we should show that as well. Okay, now back to business. So we have 2 comma 2.3. Okay, so 2.3 is going to be right about here. 0 comma 1. All right, 0 comma 1 is going to be right here. At negative 1, we have the asymptote, which we already know. Negative 2 comma 5 is going to be right here. And then negative 4 is 3.7. So negative 4, there's 3.7. It's going to be right about here. All right, so the branches, all right, will be in these corners, in these quadrants. So it's going to be like this. Well, let me not go all the way out there, though. Okay, so it's really going to end right here. So it's going to be going like this. Okay, and this one is going to be going like this. All right, it won't go any further than that because our purple part only goes from 2 to negative 4, or from negative 4 to 2. All right, so it's just that, and it stops right there. All right, now let's do the green part. We have negative 4 comma 1. And this is going to be an open circle. So negative 4 comma 1, we're going to have an open circle right here. Negative 5 comma 3 is going to be right here. Okay, you know what? I think I'll erase the extra asymptote so it doesn't look like that's doing anything, because that only applied to the purple part of the graph. Has nothing to do with this green part. So, okay, so negative 5 comma 3 is going to be right here. And then negative 6 comma 5. Okay, so negative 6, 3, 4, 5 is right here. And then it would have been negative 7 comma 19. So 19 is going to be like way, way, way off the graph, way up high somewhere. Now, remember that this point, the point that was 5 comma 0, was the inflection point where it curves from being down to up. Now that point is now right here. So please keep in mind that this is going to be an inflection point. Okay, so that's why when you do your curve, don't just draw the line straight through like that. That's not what this did. Okay, this graph has a nice inflection point. It curves one way, and then it has the inflection point, and then it curves the other way. All right, that's what we're going to be doing right here only it's just reflected the other way. So we're going to do a concave down and then concave up. Okay, so it should be curving something like this. Okay, and then it will curve up like this. Okay, let me try that one more time. Because it's got to pass through this point, of course, which is just a little bit tricky. All right, something like that. That's pretty good. Okay, that's a little bit better. All right, anyway, that is how you transform a crazy piecewise function like this.